Well, good morning, ladies and gentlemen. If we can just get to the right presentation. Okay, so 20 minutes on risk, but it's a PetroMall view of risk, which I'm sure will be shared by the industry also. The author is Greg Coleman. Greg Coleman was a vice president with BP before he went off to Kazakhstan. He's since left Kazakhstan and has branched out even more. Graham began with BP and then moved to BG and was director of operations in Kazakhstan. He's now working in Angola. As for myself, I guess what I would most readily admit to was being head of petroleum engineering at Heriot-Watt for 7 years. So, petroleum risk management. And I'd like to begin by making the point that the risks to us are absolutely pervasive. So they begin with exploration through to and pass through to abandonment. And there's a list of possible risks in the bottom bullet point, including things like, for example, security. But what underpins a lot of these risks is a deep technical understanding which translates possibly into economics and possibly into HSE type challenges. In fact, I think quite often the categorization of risks is quite artificial. Everything is bound up together. So our approach to risk management is to say that knowledge is just not enough. In our experience, this leads to box ticking. I've seen it in 2 industries. I've seen it in mining, tragically, and I've seen it in petroleum. What you require is an understanding. That enables you to ask, why am I doing this? And gently to say, is it correct? So we absolutely preserve the right to take a total quality management approach to risk management and allow everybody to have their say so that what we're using is the best possible understanding as we go forward. Sorry. Okay, so what we have here is a Boston Square. I wish I'd invented this, actually. I think the Boston Square is one of the most powerful analytical tools that there is. And what we've got on this axis is what does a company know and understand? So what is the company's human capital capable of? Not only in terms of understanding, but also what can it do? And we would humbly submit that the position of a typical operating company is probably there. Some of them would claim they're way up here, actually. You probably know them. It's their way or the highway. And a training company's mission would be to take the human capital up the what does it know and understand. And a service company's typical mission would be to take them along the what can I do axis. I think in risk management, you've got to try and take people up here, because the doing enhances the understanding. I'm not suggesting that you get into rig management and rig ownership. That's a little bit extreme. But way before that, there's a lot which can be done to make sure that the understanding is totally there. There are actually companies down here as well. You may know them. Some of them have got a surprising amount of money, a really surprising amount of money. And the challenge for them, of course, is to take them probably along this axis. It's being a wee bit too ambitious to think that these people in this category can come up take them up this axis rather than the do axis. So the Boston Square. Now let's move into new frontiers. Let's try and set this strive for understanding in the context of new frontiers. And for me, there are 2 challenges. It's a new location, and fractured basement seems to appear there. So the 2 challenges are these. I guess the root cause of the challenges is that the traditional approach of looking over your shoulder and saying, what is the first guy in there doing? Or what have we done in this kind of circumstance before? That opportunity is not necessarily there. You know the trick about being a fast follower and so on. That trick may not be possible. And so there is a genuine need to consult widely, and under the current financial pressures to consult efficiently. So let's look at this a little bit in the context of Claire I guess that's getting into the North Atlantic. And let's look at the consulting thing on the basis that there is a lot of understanding there. There is an absolutely huge amount of understanding there. And I'm personally aware of the understanding locked up in rock mechanics in Heriot-Watt University. So rock mechanics was my research field before I lost my way and went into management. So let's look at this chase for understanding in the context of Clare, which is a fractured basement reservoir, and in the context of what I know about Heriot-Watt. There's a lot of information on this slide. I think one of the main point I'm trying to get across is that industry, with its GIPs, invested a huge amount in research, in universities with other consultants and so on. But when you look at who funded it and who actually took it up, it's a very, very small percentage of that understanding actually transferred into application. It's not unusual for a typical GIP to have 5 sponsors and maybe 2 companies, 2 of these 5 actually pick up the results and do something with them. The other people are kind of relaxing in the sense that they're in a club, they can talk to one another, etc., etc. That's the value of the GIP to them. But in actually implementing the understanding produced, quite often falls by the wayside, particularly if the people liaising with the research group from the company move on. But all that understanding is retained by the university. Some is in the public domain, not all, but it's all retained by the university. And as I say, I'm going to take rock mechanics as an example in Heriot-Watt. So let's look at this, and some people in the audience will kind of recognize this, which is, for me, reassuring. We're going to look at the stress sensitivity of the reservoir. The value of the projects done in Heriot-Watt in that topic, conservatively, about 5 million. And what I'd like to look at here is a specific risk, the lowering of recovery factor because of, if you like, poorly designed water injection. So just to set the scene, here is, I'm sure you will recognize this, Clare must sit somewhere here, and it's a fractured basement reservoir. Basement in the sense that it was originally below the source rocks. So it's uplift that's brought it up above the source rocks. It's not basement in the true geological sense because it's not igneous. So you'll see this BGS diagram shows the igneous rocks as a genuine basement, but we're calling this a basement reservoir. The true basement squared reservoirs are, for example, the granite reservoirs in Vietnam. But it's fractured basement. So how are we going to address this? We know it's fractured. What kind of conceptual model are we going to put together? In fact, I'm going to suggest this is a conceptual model that applies to all reservoirs. So the mantra is this. The reservoir consists of intact rock, blocks or layers of intact rock bounded by discontinuities. 2 types of discontinuities, as you'll see in a minute. The stresses on that reservoir are anisotropic, so it's got a bigger squeeze in one direction than the other direction. Absolutely fundamental. Absolutely fundamental also is that the production process changes these stresses, either by reducing the pore pressure, so the ground feels more of the overburden weight or the incumbent stresses, or indeed by changing the temperature, for example, by water injection. And because of all that, the ground reacts. Oh, I've killed my big joke. Anyway, look forward to it. It's the next slide, right? The next 2 slides after this. Okay, so there's the there's a picture of what could be a typical reservoir. Intact rock bounded by discontinuities. Importantly, 2 types. There's what you might call fractures or joints, which are kind of normal to bedding, but these discontinuities running parallel to bedding are absolutely key, and for me characterize the way this ground reacts in a pretty unique way. So, intact rock bounded by discontinuities. So if you're a sculptor, you've already, you know that. So if you're going to do something which is vaguely life-size, see where I was going? Then what you need to do is find a piece of marble that is, 3 meters high, 2 meters square, and away you go. A big block of rock between the discontinuities, and you can create a marvellous work of art. This one's shared between Edinburgh and London, actually. And I would recommend you go and see it. I would stand back and watch the smiles on people's faces as they come into the room and see it for the first time. It's quite a sight. I put that on because of modesty, I guess. But if you're a little bit more ambitious with regard to size, you've got to work with the discontinuities. So here is something which is a little bit more ambitious. It's still carbonate, but you can see that the body of the Sphinx clearly demonstrates bedding parallel discontinuities and fractures. Now, if you're going to carve a face, a big face, you need a lump of solid rock. So when you move up to the section where the face is, you'll see that that is pretty free of discontinuities. But if you look carefully, and you remember this thing about myth about the proportions of the Sphinx's face and the smile on the face of the Sphinx and all that kind of stuff. If you look carefully, you'll see that the mouth is on a discontinuity. And the nose is also. You can see I'm shaking. So there you are. Sculptors know about blocks of intact rock separated by discontinuities. And if you look in well logs, you can see these things. And so quite often what happens is that the things are there, but they're not recognized until people begin to ask questions. Have you seen this? And you see the light coming on. Oh yeah, we have. So let's begin to build the conceptual model. Intact rock, bounded by discontinuities. The two types, remember, bedding parallel and not quite vertical. Let's put the anisotropic, I can never say that word. Let's put the stress state on the thing. And that's what we end up with. A reservoir sitting squeezed by different horizontal stresses and obviously loaded vertically. So what does that conceptual model begin to predict in terms of risk? Well, it begins to predict things like compaction, wells towards the center of the reservoir probably being damaged, possibly being damaged in compaction if that is high. It certainly predicts shear along certain horizons. That shear can be big, as in the case of Ekofisk. So Ekofisk regularly loses wells at a known horizon because of shear. Or it can be small enough not to be noticed, but I believe it's there. Or it can be possibly the cause of something like Elgin Franklin. But it also predicts that if there are fractures in here, I contend that they are always there. It's just that sometimes the way that they react is not big enough for the reservoir engineer to see them. But if there are fractures in there, then they will be activated as we change the stress in the reservoir, and we'll see the effects of that on production. And also, in some cases, you can activate faults and change the compartmentalization. So that's what that diagrammatic conceptual model, underpinned by lots of measurements and observations, and predicts. So the next step is to take something with that conceptual model and begin to be able to put numbers on things. So how much shear are you predicting? Which fracture set will be activated, etc., etc. And here is a kind of workflow which summarizes a lot of the work done at Heriot-Watt, which looks at what I've called matrix here. That's the intact rock. Looks at the fracture properties. Looks at in situ stresses, and by various tricks and correlations, using seismic anisotropy, for example, to get at fracture distribution, possibly in orientation, produces this geomechanical appraisal. And out of that geomechanical appraisal then, with the properties in, you can begin to do things like apply coupled modeling, and in fact do some back of the fag packet type calculations also. this works, and really one of one of our missions at Heriot-Watt used to be to assemble the various bits of understanding that you had to put together to make this workflow possible within allowable economics and within allowable time constraints that the industry always imposes. So let me show you a couple of things now. Let me explain how coupled modelling works, and I don't know how long we're going back here, Kez, but it seems a long time. We begin with a conventional fluid flow simulator, which of course is going to tell you how pore pressures change, temperature and saturations change. And we would then translate these into changes in effective stress. These production-induced stresses then are put into a stress analysis simulator, which runs and produces rock movements, change in stress and strain, and then from that a change in permeability. So the changes in permeability would go back into the fluid flow simulator. And we began by doing this kind of laboriously, coupling Eclipse with existing finite element programs, but it's now got other people have taken it and made it get quite a bit smoother. So I would contend that what comes out of here is a more realistic prediction of how the reservoir is going to produce. But also what comes out is a prediction of strains and displacement. So you can begin to see where wells might be under threat due to shear, for example. Or you can begin to see which fracture sets might be activated and how injectors and producers should be spatially oriented to maximize production. So let me show you something about displacements. I'm not going to tell you how old this is, but this is a vertical section through a reservoir, very much like the section I showed before. But what you can see on here, these are vectors of displacement. So red is more displacement than green and blue, etc. But you can see that there is always a sideways component to the displacement, as the reservoir in here is gently compacting because the pore pressure has been reduced and therefore the effective stress on the reservoir increased. So this absolutely stands up to something that we see in industry, something that I've seen up to 2 miles depth personally in South African gold mines and stratified deposits. The ground, if the ground is going to move vertically, it would always inevitably move sideways as well. So it would have been interesting to do this work on Elgin Franklin, and I believe it has been done on Ekofisk as well. So the sideways movement, the shear risk is being brought out here. Let's look at fracture set activation. So this is a plan view of a very simple reservoir, but it does have a fracture set with the horizontal stress in this direction being less than the horizontal stress in that direction. Which means, if you think about it, that fracture has got less stress, force holding it together than maybe a fracture sitting here, the fracture sitting here, which has got the bigger stress acting on it. Actually, the orientations could have been a little bit more extreme. But let's run this with coupled modelling. And again, this is a pretty old slide, and this is with recognition to the work done by VIPS. That shows an injector here. There's a producer here. We'll see what happens to saturation in a minute. But what this is showing is that because the horizontal stress in this direction is less than the horizontal stress in this direction, this fracture is opening against the path of least resistance, perpendicular to the least confining stress. And if we move forward through to the saturation, you'll see that that's a very nice flood front because the injected water is moving it in this direction away from the producer, so that we get a very nice or a pretty even sweep efficiency. I don't have the opposite situation. This has survived transfer to about 3 laptops over the period, and unfortunately I've lost the opposite case. But that's what you're aiming for, to get the fracture set that you want to open in relation to the position of injector and producer. Here's some gems. I talked about this bank of understanding up in Heriot Watt. Here's some gems that are still locked up in there, that some people are aware of, and some people, and a lot of people are not. In order to make that workflow work that I showed you about getting the mechanical properties of the rocks right with a feasible budget and in a feasible amount of time, we decided to correlate as many properties as we could with porosity. And we began with North Sea sandstones. And there are very good correlation curves for things like Young's modulus, angle of internal friction, all the things that get rock mechanics people excited, and porosity for sandstones. And you think it should kind of work for sandstones. We were then bold enough to suggest it might also work for carbonates. Aramco didn't quite believe us, but that's a correlation curve for carbonates. I can't remember which one I picked, but there's a whole family of correlation curves for carbonates and sandstones. So that this step between the petrophysical log, the petrophysical model of the reservoir, and the rock mechanical model is very easy to do. So if you give me your best porosity model for the reservoir, I can instantly translate it into a rock mechanical model, certainly as far as the properties of the intact rock is concerned. There's also a nice thing sitting way, way back in history. We've got rudimentary correlation curves between clay content and shale, or what I would call mudstone properties. And that goes right back to the mining engineering roots of this rock mechanical work. So that's one of the gems. When the world is ready to admit that the ground is really anisotropic, there's a test cell sitting up there, which is, I think was the first and maybe the only one, which can produce anisotropic stresses on circular plugs. So you can see how the testing regime is being developed to suit the conceptual model, which and make that as realistic as possible. The world is not quite ready for that yet. The other unique piece of kit up there enables us to, or enables Heriot Watt to shear test discontinuities, but with more than the uniaxial strength of the rock acting on it. And to do that, of course, you've got to confine the sample. So there's a test cell which confines the sheared sample and puts the confining stresses on the sheared sample, enabling you to shear at very high axial loads, very high normal loads across the interface. ExxonMobil recently commissioned some work on this rig, so they're kind of wakening up to things. And that's just some examples of what's sitting up there. And things like that will be sitting in other universities as we go. So there's this bank of understanding which can contribute to risk management. But how do you get at it? Well, what PetroMall is in the process of doing is creating an intelligent social business network. What that means is that it is focused, it's directed when required at specific problems, but it does offer a stimulating environment for people to contribute to. If you like, it will be, discussions will be moderated. There's an opportunity to upload information. So it's like LinkedIn 2 or 3 generations on, actually, and uses connection software. So what we are suggesting is that a very good way to get at these experts who are sitting leading their research groups in universities around the world is to provide this connectivity. But of course, it's not just universities that we want to connect in. It's consultants who feel they've got something to contribute. And PetroMall will be quite eclectic in its mission. We said that risks go right through the industry. There was a security risk up there, and we're pleased to be involved with a former senior BP consultant who's got a bit of a reputation. What do you think he sees as the biggest risk for the North Atlantic in a security context? Any suggestions? Is it foreign terrorist gunboats coming in? Is it low-angle model planes? Is it drones flying into rigs? Hurricane. I mean, that could be a good one. Icebergs. Well, you can see them coming at least. No. No, he thinks, and this I think will apply.
Hacking the SCADA system.
That's it. Cyber attacks. So what he's suggesting is the industry should wake up to that and try to do something about it. If you like, harden their IT. I talked about understanding being important, and this ability to communicate, which of course is one of the fundamentals of the kind of TQM approach. So here's a route map. Oh, geez, keep doing this. So the challenge is identified. It involves academia, I guess, both branches of industry, the operators and the consultants, and PetroMall. There's a commitment to share and set the knowledge and understanding in its appropriate context. And in this case, we've been talking about risk management. Make sure that we ground that as much as possible. Seeing is believing, feeling is believing. Let's see if we can predict with conviction. So the work goes into practice, which again helps to build the confidence, but inevitably change will be required, and we hope in this stimulating environment that change will naturally flow into the system, which kind of enables the challenge to be reworked. And so the conclusions. There is a huge bank of understanding out there. A lot of it with universities. That's what I'm personally most familiar with. And you know, and in being in London, I need to admit that there's another university called Imperial College, I believe. I mean, both Imperial and Heriot Watt are absolutely typical of what is out there. And within the older generation, which has just retired from the industry as well, I mean, a wonderful bank of understanding. If we can access this, then that would help with the development of new frontiers where there isn't this opportunity to look over your shoulder or recognise what you've done before. And we suggest that intelligent social business networking can accelerate that process. So finally, can I acknowledge my colleagues in PetroMall, former colleagues in Heriot Watt University, and I'm pleased to see at least one here today, and VIPS Limited. Here's the story. VIPS, that modelling work that I showed you, the two little movies, was done using a couple modelling software developed by VIPS. It was so good that Schlumberger bought them. So there's another way of getting understanding out there. So thank you, and I'd be delighted to handle any questions.
Brian, that was really interesting, Brian. One thing that strikes me looking at your knowledge bank is presumably it's a service to oil companies. And you've got to know what questions to ask the knowledge bank to start the dialogue. And particularly your example of Heriot Watt, you needed to know to ask that question before you approached Heriot Watt. So how do you begin that interaction with the group of experts? How do you know what questions to ask it? Is it innate or?
Yeah. Well, I guess I mean, there's a couple of ways that I think to do that. I think we're pretty, one way or another, we're pretty well connected with the industry. So we know what the challenges are, and therefore what we can do proactively is assemble a group of consultants who we feel would be able to address these challenges. The consultants will be given an opportunity to run a blog. If they're academics, they can blog with impunity, actually. Academic freedom is a wonderful thing. It's a great attribute of this country. What we would then see happening is that the consultant begins to stimulate some dialogue through their blog, for example, or the companies who have engaged with PetroMall by becoming members bring their own issues to us. So I think it's this kind of mixture of us being proactive and, if you like, going for what we think the industry should be asking about, and the industry being curious enough to look at what's happening on PetroMall and decide, these guys might be able to help. This process, let me depersonalize it. This process of stimulating interaction in an effective way may well be able to help us.
Any comments or questions from people here?
Certainly, as an academic, yeah, but that's right. What you call attitude to take, that you are generators of knowledge, and you want that knowledge to be shared. And it's true that through interaction, we not only disseminate knowledge, but also we grow knowledge. But our oil companies also compete on knowledge. I mean, they have at times to be secretive. Now, how do we overcome that difficulty?
Well, I mean, in my experience, if you look at the majority of the GIP, the Joint Industry Funded Project work, for example, let's separate it. Okay, Research Council funded project work can be published without any restrictions. In fact, it's absolutely required to be published to enhance the reputation of the university as seen by the government. It's a little bit more complicated with joint industry funded projects. In my experience, you can always publish something. But remember, research is by definition ahead of its time. And here's the crunch. In my former university, the contract was written in such a way that all intellectual property reverted completely to the university after 5 years. So what the university is saying, right, to the companies that fund it, you've got 5 years exclusive use of this stuff. But then we can do what we like with it. Now, if it's ahead of its time, it may well be that after 5 years, the industry is just the mass industry, or enough people in the industry are just about ready to accept it. It's a very, very conservative industry, the petroleum industry. And therefore, a lag of 5 years for me is not a big disadvantage.
Because you're making the premise that risk management comes from increased understanding, and increased understanding is in the academic community or outside an oil company. And therefore, to reduce your risk, you have to access that pool of understanding. Is that the premise behind PetroMall? Yeah,
I think partnership is the key. What I'm saying, what I deeply believe is that if you look at a particular risk, the industry, and I shouldn't generalize, there will be deep pockets of understanding with regard to that risk within the industry, without any doubt. But there's an opportunity to kind of spread that through the system, but also to make sure that that understanding, however deep it is continually being enhanced. And if you like, it's almost the mission of a research group to keep posing questions. Okay, you invested in helping us build this model. This model is now predicting this. Can you see this? Have you looked for it? So that's that interaction for me, which is quite powerful. So no ivory towers, no sand faces. Let's find somewhere in the middle where we can cooperate and make sure that all the risks, including importantly HSE, are managed to the best of our human capabilities.
Any comments or questions from people here?
You didn't say anything about checks, as in money. Is it universities going to help happily because they have the expertise and they'd like to share it? Is that how?
Well, no free lunches. I think if you look at the financial inputs to try and make this thing work, the university would be, if you like, bringing into the operation access to all that amount of research, but so that's a big donation in itself. But access to that would be for a fee. So there'd be a normal consulting fee paid to the university consultant or the retired industry person consultant to get their bank of understanding along the lines that the industry would understand. So that's a kind of one-to-one thing. But in order to get into that, you may want to become involved in our online communities. And what we see happening there is that there will be a modest fee paid by the individual. So what we hope is that the whole thing becomes economically sustainable, recognising the different inputs and the different charges.
Well, thank you very much indeed, Brian.